Alright, in today's video we're going to learn how to use West Point Bridge Designer on your desktop. And you log in, click on Bridge Designer. I know it's 2016. They used to have a contest. They don't longer do the contest, so this was the last time they updated it. Just say OK. We're going to create a new bridge on this first screen. Okay, and this shows you can change a lot of different things without your bridge. We're just going to click Next through this first time through. We're not entering a local contest, so say no on this screen, click Next. On this one, you can change your deck elevation to a lot of things. You can lower it, but you'd have to cut away things. For this first try, we're just going to start at the very top. You can change your abutments to have an arch or a standard. We're going to stick with standard. You can add piers in the middle. We're going to just leave ours standard for this first one. These are all things you can change when you design your own. And then you can add cable anchorages if you want. So there's a lot of things you can change, and you notice it's charging me for the bridge because we have just a basic bridge, so the cost is going up right now as we add things. We're going to put it where we're going to have trucks going side by side like this. We could do it with just a single. We're going to stick with the two. We can change the type of concrete, and you notice when we change the style of concrete, whether it's medium strength or high strength, you gain something by making it thinner, and it might be lighter. But if you look at my cost, it goes from 67 down to 63,000 when I change it back to the medium. So everything comes with a cost. And again, when you design your own, you'll be able to change some of these things to try to improve the cost by still making a structurally sound bridge. But again, we're just going to stick with what they give us for this first try through. Okay, so click Next again. We're going to do a through truss, and we're going to start with a Warren. Okay, and you can see it gives you that. You can see if you change. But for this first one, we're going to do Warren. A deck truss is where it's built underneath. Okay, but we're going to go with the through truss Warren for ours. Again, when you're building your own, you can change what you want. You can see the price really hasn't changed yet for us on this one, but sticking with Warren so far. Here, you want to put your name that who it was designed by. And then project ID, this is just your class period number, so maybe you're in third period. Click Next. It just tells you some things how to design, and then you click Finish, and it will set up your design. Now they went ahead and put the where you're going to make joints here on the bottom. You have to add the joints to the top. So over here in the tools, you have the joint tool selected. You just have to put a joint. So just put a circle wherever there's a circle. Okay, put the gray dot everywhere there's the circle. Once you have all those filled in, then you're going to go add the members. If you're going across a bunch, you can just do them all at once, and it will know those joints are there. That'll save you time, and then it takes a little bit of time because you have to draw each one of these individually. I'll do this really quick so we can move on and show you the next step. Okay, and you notice every time I add a beam, my cost is going up. So if you look up here at the top, you can see the cost. So each one of these beams is like $6,000 to add that thing on there. Okay, so there is my bridge. It's good enough, right? It's holding up, it looks great, but we got to test it. So up here at the top, it's the fifth one in. It shows the drawing board, which is where we're at. We want to look at run the load test. Okay, so we're going to run this load test. Puts it there. Oh, it doesn't even survive the truck that's going to be coming along. He's like, not going through there. Okay, so it doesn't work. See, the status was bad. So we're going to go back to my drawing board, and now it tells me, look, these are the ones that failed. They put the little lines on them. And over here on the right-hand side, you can see where they failed. Now it shows us forces in compression and forces in tension. Okay, so you can spread those out just a little bit so you can see those. If it has a number under compression, that means it's in a compressive state, and we would use one type of beam. Usually a hollow tube works better for compression. For tension, you can see those have numbers. See, some of those have 0. So where there's numbers in the compression side, there are no numbers in the tension because it shows me that that beam is being squished, compressed, and not stretched or putting under tension. Okay? So if we go over the number 1, that means it can't handle the load. Anything under 1, you see how these that are under 1 aren't highlighted here or there. Okay? And so we need to change those and make them bigger. So we could change all of these right here. First, they're all bars. Okay? tubes are usually better in compression. So we can go over here and we can change this solid bar to a hollow tube. And once we've done that, we can go try this again. Did that make a difference? So we go back and run our load test. It didn't do any better. Okay, so there's other things we have to change. You notice, look, they went way up. Okay, so maybe we just have to make those bigger tubes. All right, so let's make them much bigger tubes and then run that thing again. Okay, still failed, not quite as quickly or as badly. Let's go back and look at our numbers. Still higher. So let's just try to make sure it works this time. There we go. So it held up, but and we died. So not good. But look, not as many. So we just have to change these middle. Okay, now there's a bunch of other things we can change, right? There's other things that are under compression that are still bars. So maybe if we change those to tubes, that would help these. Because these bars here are affected by all these other beams. So you have to change a bunch, just like this one at the top, right? We never changed the value of this bar here to something bigger. And so as we change one thing, it will affect others. And so kind of it's just going along, testing as we go, and seeing how things work. See, oh, I got a little closer that time. Okay, so we're just barely over. So maybe we just had to change these 4. Let's make those a lot bigger. We just want to get this done so you guys can see what happens. We made them huge this time. Did that help? Oh, come on, bridge. Oh, he was so close. Now look, son, another bar broke. So we fixed those, but that put too much stress on these guys. So now we can change these, right? Okay, so I'm trying to just get it to work one time. And you can notice here, there's things that are in red and things that are in blue. And as the truck goes across, you notice how some of them, they change their colors a little bit. So what that's showing me is what's in tension and what's in compression. And we survived, yay. So the compression ones are the red and the tension are the blue. And so we can now go change things around. But look at my cost, it's $403,000. You know, making those tubes bigger makes those things more expensive. Yes, we have a working bridge, but nobody's going to want to pay for our bridge because some other company is going to make a much cheaper bridge that still works. So now your job is to go make this as cheap as possible, right? So try to change all the things that are bars into tubes if they can, right? So this is a bar that's under compression, so we can change that to a tube because tubes are usually cheaper. Watch, when I make this a tube, I went from 403 down to 400,000 by changing one thing. And if I run it, oops, now it's going to die, so we got to fix something else. Okay? But we're saving money. So maybe a tube that's, you know, a little bit bigger is cheaper than a bar that is skinnier. So you just have to play around with this until you can get a bridge that works. Our goal for this first one is to get under $300,000. So we've got some work to do. But you can see how we change things back and forth. When you're building your own, you can change a lot of different things. You can change what it is, what kind of steel. You can add a pier in here. What if we had a pier right there? Wouldn't that make it much easier because we'd have another support? We could cut our bridge down and only make it this long. If it's shorter, it won't take as much, but it's going to cost us a lot of money to dig away that dirt. So it's a trade-off. What makes it a stable, good bridge, and what does it in a cheaper way? All right, that's how it works. Good luck. Have fun.